Hi, apologies. I haven't done many of these, but I'm going to do as many as I can today. I'm going to do exponential and logs, followed by the applied questions. And then from there, what we can do is hopefully help as many of you who've got assessments left. Otherwise, for those of you who are maybe watching this later, this is exponential and logs. It should be useful. It's based on the 2021 assessment material, and we're just working through the questions. Okay, so let me pull them up. Okay. So question 1, we've got given that. So given that 2 log 4 minus x equals x plus 8, show that. We know from our log rules that we can bring up powers. So this 2 can come up as a power. So we end up with log 4 minus x squared equals x plus 8, log x plus 8 even. So we first have to clean out the logs. Once we've done that, there's just log on both sides, so we can get rid of that log, and we get 4 minus x squared equals x plus 8. When you open out the brackets, you get 16 minus 8x plus x squared equals x plus 8. If you move everything onto one side, you move the x onto that side and the 8 onto that side, you end up with a solution. Then it says write down the roots. When it says write down, you don't need to solve anything. You literally need to either plug it into your calculator, or it's going to be something really, really obvious to see. Now, if you put that into your calculator will tell you that you get x equals 1 and 8. If your calculator doesn't, you haven't got the equation function to put it in, we'll factorize that quickly. We can see x and x, 8 and 1, minus and minus equals 0. So x equals 1, x equals 8. Now we're going to state which one is not a solution. What do we know about logs? Now, if we think about logs, log anything or ln anything has to be positive. If we were to stick 1 into here, 4 minus 1 is 3, that's fine. 1 plus 8 is 9, that's fine. Let's plug 8 in. 4 minus 8 is minus 4. So that's impossible. So it's not a solution. So you'd say 8 is not a solution. Log 4 minus 8 can't be found. And that would get you the marks. All right, next. By taking logs of both sides, solve the equation. So they're hinting you. They're telling you to take logs. Now remember, when you have logs, they're to a base. But if you write log, we either assume it's to the base 10, or you could have ln, which is to the base e. So when I take a log, I'm moving it down. So whatever's in the power comes to the front. So I'm going to get 3p minus 1 log 4. And in your calculator for this, you can use ln, log to the base 10. It doesn't matter what log, any log that you have, equals 210 log 5. So the 210 comes down. I want to divide, I'm going to divide the log 4 on both sides. So 3p minus 1 equals 210 log 5 divided by log 4. So 3p equals 210 log 5 over log 4 plus 1. I type that into my calculator, and then I would do answer divided by 3, and to 1 decimal place, I get 81.6. There's a random integration question in here, but we'll do it anyway. I guess maybe it comes out with lens, let's see. So given that k, okay, so this means it's a positive integer. Show that between 3k and k is independent of k. All right, so we're just going to integrate. Whenever we integrate 1 over something, so the integral of 1 over x is ln x. Now, if we have plus c, and if we have the integral of 1 over ax plus b, it's going to be ln of whatever's on the denominator divided by the coefficient of the x. So that's the case we've got here. So when we integrate this, we end up with, so put it in square brackets, 2 ln whatever's on the denominator divided by what's in front of the x. And what's in front of the x in this case is 3. And that's between 3k and k. So then we're going to sub it in. So we get 2/3 ln 3 times 3, 9k minus k. So that's going to give us 8k. Minus 3k minus k, which is 2k. Now your log rules tell you when you've got a minus and you've got lns, you divide. So this is going to be the same as 2/3 ln 8k over 2k. The k's are cancelling, that becomes 4. So you get 2/3 ln 4, and you've proved it, because independent of k means the answer doesn't depend on k. And if you have a look, you've got 2/3 ln k, there's no k's in there. So you're done. Right, next one, show that P is inversely proportional. So let's first rewrite this in indice form because it's not a 1/. The biggest mistake students sometimes make when it's over x squared and they write it like that, you're like, oh, it's lns, I know 1/. It's not lns because it's to the power of -2. When you add 1 to the power, you get -1. So we're going to add 1 to the power, divide by the new power, make that minus, and by whatever's in front of the x. And that's between 2k and k. So we end up with minus 1/, because these two cancel, 2x minus k. Now let's sub that in. When we sub in 2k, 2 times 2k is 4k, minus k is 3k, so we get minus 1/3k, minus, so that's going to make a plus 2k minus k, which is plus 1/k. So we end up with 1/k minus 1/3k, so we get 2/3k, and we can see it's in proportional. So you could write the fish sign, which represents proportional, 1/k, or you could say which is inversely proportional to k, because there's a k on the bottom. So you've proven that next point over there. Right, next question. I think I jumped one. Okay, a research engineer is testing the effectiveness of a braking system. We've got two graphs, d against v, and then log d against log v. Explain how figure 6 would leave the brake should be modelled by the formula with k equals 0.017. Okay, so he believes that the formula they should be using is d equals kv to the n. Right, now if we look at that line, it's not kv, it's not d against v, it's log 10d. So I'm going to take log 10 to get log 10d on one side, and that means I want log 10 on the other side as well. Now my log rules tell me when things are multiplied, it's the same as adding them. Plus log 10 v to the n. Also tells me if there's a power, that can come down. So I get log 10d equals log 10k plus n log 10v. So now if I was going to compare that to my normal y equals mx plus c, in this case, y is like log 10d, which I've got, and x is like log 10v. So if I have a look, log 10v is here. So this value of n must represent so that value of n represents my gradient. Now I also have a plus c. plus c is where I cross the axes, which is represented by log 10k. So I know that log 10k is equal to minus 1.77. Now remember the way the logs work. This means 10 to the power of this equals this. So k is going to be 10 to the minus 1.77. And when we work that out, we get 0.017, which is what we're trying to show there. And then it says, find a complete equation for the model, giving the value of n to 3 significant figures. So this time I'm going to clear that. So this time what we now have is we now have a coordinate here. We know that when v is 30, d is 20. Yeah. So we can plug that into this formula. So we have d equals, and we work that out to be 0.017 times v to the n. We also know when d equals 20, v equals 30. So 20 equals 0.017 times 30 to the n. We can do 20 divided by 0.017. So wait, I should say 30 to the n equals 20 over 0.017. So therefore n must be the same as log, this is your base, to the base 30 of 20 over 0.017, which gives me log 30 answer. So n equals 2.0, how many significant figures? 3, 2.07. No, 0.8, I didn't round. So 0.8. So my final complete equation, I'm going to rewrite it, is d equals k, which is 0.017 times v to the 2.08. Sean is driving this car at 60 kilometers per hour. Okay, and v is measured in kilometers per hour. Okay, perfect. So we have our v. And he notices a large puddle 100 meters ahead. It takes 0.8 seconds. See whether he can reach it. Okay, so first of all, I'm going to sub in when v equals 60. So when v equals 60, d equals 0.017 times 60 to the power of 2.08. So I get 84.918. And this measures your braking distance. So his braking distance is 84.918. And to that, what I'm going to have to add is the time it takes him. So if it takes 0.8 seconds for him to react, how much longer is he driving for? So, sorry, apologies, there's somebody at the door. Okay, that's fine. They've left the delivery outside. And he is going at, what do we say? He's driving at 60 kilometers per hour. So in 0.8 seconds, we've also got a distance of, also got to add a distance of 13.33, which gives you 98.251, and that's less than 100, so he definitely stops in time. Okay, so hope that makes sense. Right, next. Question 5. All right, so weed is completely covering the surface of the pond. Apologies, I just got distracted by the postman leaving something and trying to tell him not to, that was the strange look on my face. That was me looking out my window telling him not to ring the doorbell. I think he got a message. Anyway, weed is completely covering the surface of a pond. Fish are introduced into the pond in an effort to control the weed. A surface area covering the pond t days after fish are introduced is modeled by this equation. State, so you see the word state, it's something easy. You shouldn't have to think about it too much, right? At the start, t equals 0. So when t is 0, e to the 0 we know is 1. So all of this bit is going to become 1. So you're going to be left with 105 minus 12. So you're going to get 105, take away 12, which is 93 meters squared. A mistake a lot of students make again is just looking at the 105. But remember, anything to the power of 0 is 1. So find the time taken for the surface area to fall to 40. So we're going to make this whole thing equal to 40. So we've got 40 equals 105 minus 12e to the 0.08t. So when we rearrange that, we get e to the 0.08t. So 105 minus 40 divided by 12. Actually, let's just do it this way. So 12, move that onto the other side. 105 minus 40 to give us 65. So e 0 to the 0.8 t equals 65 over 12. To get rid of e, so the opposite of e is ln. Even on your calculator, e and ln are on top of each other. So it's just like square and square root. It's just how you get rid of it. So to get rid of the e, we're going to ln both sides. So we get ln 65 over 12. And we end up with dividing that by t, and we get 21.1 days, because it's all done in days. Okay. Stuart wanted to predict the surface area 30 days. Explain why he should not use the model. Right? Well, first, it tells us the model can be used for anything bigger than 0. But if I stick t equals 30 into the model, a is 105 minus 12 e to the 0.08 times 30. And you end up with minus 27.3. Now you can't have negative surface area. So you'd say it gives, you'd have to write a sentence to get the last mark. So it gives a negative area, which is not possible. Which is not possible. All right, give Stuart will get a negative area, not possible. Try and make it in context to the question as much as possible. Right, question 6. Oh, okay. Right, the amount of antibiotic placed in a bloodstream is modeled by the equation. Show that the equation can be written. So again, we do a comparison. Instead of y, they've got log 10y. So what we're going to do is take log 10 of both sides. So log 10y equals log 10 ab to the power of t. Now using our log rules, we know that means a plus log 10b to the t. Then again, we can bring the t down. T log 10b. And then we can rearrange it so it looks like that, t log 10b plus c, where c equals log 10a. So they just replace c with log 10a. A doctor measures the amount of antibiotic for the first 5 hours. She plots a graph and she gets a gradient and a y-intercept. So we've got a gradient. Now remember, if we were going to think about this in y equals mx plus c, our gradient bit, if you like, is log 10b. So log 10b must be the same as minus 0.076. And my c, which is actually log 10a, is 2.23. Now remember to open that out and get a to b on its own. It's 10 to the power of that equals b. And then 10 to the power of 2.23 equals a. You plug those both into your calculator, and to two significant figures, you get 170 and 0.84. Now it says, give a practical interpretation of the value of the constant a. So if I think about it, if I'm going to put a value into here, that's only if t is 0, I'd end up with a, so I give it for the value constant a. So you get 170, and that's going to happen because if t is 0, anything to the power of 0 is 1, you're going to left with y equals a. So that is when t equals 0. Now, what are we talking about? We're talking about hours after the antibiotic. So at 0 hours after the antibiotic is given, there's 170 milligrams. So that just means, so A, 170 milligrams are given initially. Or at the beginning, the patient's given this much. However you want to word it, but you've got to use the context of the question. The constant b is how much it goes down by, or the rate it reduces by in this case, which is 0.84 every hour. So actually it's becoming 84% of its original every hour. That's what it represents. So you could say the antibiotic is reducing to 84% of its original, or it reduces by 16% per hour, because 100 minus 84 is 16 per hour. Give your answer. Use the model to estimate the time for the amount to fall below 30. So we're going to work out the time when it gets to 30. Now we've got A, we've got B, and we're going to put Y in as 30. So we're going to have 30 equals 170 times 0.84 to the power of t. So 0.84 to the power of t is the same as 30 over 170. So then to get rid of the t, you've got log to the base 0.84 of 3 over 17, which gives you 0.84, 3 over 17, which gives me 9. Oh God, sorry. There's me looking down at my calculator, sorry, 9.948. And then it says, for the first time taken to go below that, so I'm going to round that to 9.9 hours to one decimal place. How reliable is it? Well, they told us that it's measured for 5 hours. So it's extrapolating from my data. So I'd say it's outside of my data range. So therefore may not be that reliable. Okay, question 7. Okay, squirrels. Red squirrels. Scientists counted the number of squirrels. They found that. So these are all the same. Can you see how they're starting to look the same, hopefully? And we're going to find an equation for L. Now, don't just jump and say, I'm taking logs of everything. That is what you're doing. But look at the question. Instead of P, we've got log 10P. So that's what we've got to do here. We're going to do log 10 of both sides. A, B to the T. Exactly like the previous question. Add, because you use your log rules. Then bring your T down. And then match it up. So this is like my Y. This is like my X, if you like. So my M, my gradient is going to be represented by log 10B. Now and my plus C is going to be represented by log 10A. So I can see straight away that my plus c is 2. So we're going to have log 10a equals 2. And we can work out my gradient. So my change in y over my change in x is going to be from 2 to 2.4. So 0.4 over 20, which is 0.02. So I know that log 10b is 0.02. Right. Oh, I think I've done more work than we needed to. Didn't even need to do that. All we needed to write was log 10p, we just want the equation of L, equals my gradient, which is 0.02t plus 2. Okay, anyone who might be confused with gradient is literally just change in y over change in x. Okay, find the initial number of red squirrels that were introduced into the wood. Okay, so all that work I did isn't too bad because we need to do it for part B and C. So now we're going to use this bit to find my A and to find my B. So we're going to get 10 to the power of 2. And then we've also got 10 to the power of 0.02. So if we to write out the equation in this form. So 10 squared is 100. So A equals 100. So 10 to the power of 2 equals A. So A equals 10 squared, so 100. And B equals 10 to the power of 0.02, which is 1.047. So you end up with P equals 100 times 1.047 to the power of t. And that would be, so your initial number of squirrels when t equals 0 will be 100. And we found the complete, so we've done the whole of that bit. We've also done part C, which is to complete that equation. And the last question says, on June the 1st, on June the 1st, 2019, there were 198 squirrels. So show that this model is not valid. Okay, so from 1996 to 2019, we're going to have 23 years. So when t equals 23, p equals 100 times 1.047 to the power of 23. And that gives you 288, which is a lot more than 198. So you say it's a lot more than 198, so not valid. So why might that happen? So it might happen, I don't know, there could be somebody comes and eats the squirrels, predator effects, the land might have been used for something else, the wood might not have been big enough to sustain a constant increase in population, anything logical. I know some people find that quite hard, but don't overthink it. It's only worth a mark. Oh, sorry, we scrolled too far. Question 8. In a simple model, the value of the car depends on its age. The following information is available. Its value when new is 20,000. Its value after 1 year is 16,000. Okay, you see exponential. Your brain is going to go, forget the letters for the moment, just in terms of x and y equals something AE and to the minus kx. Now this might be plus or minus. It depends if it's exponentially increasing or exponentially decreasing. Now in this case, the value is going down. So we're going to have v equals AE to the minus kt. So we know that's the equation we're going for. And now we're going to plug in some numbers. We know when t equals 0, v equals 20,000. And we know that when t equals 1, v equals 16,000. So the first one, when we stick t equals 0 in, we're going to be left just with a. So that tells us a equals 20,000. Oh, not sure what's happening there. A equals 20,000. And so we end up when t equals 1, v equals 16,000 equals 20,000 times by e to the minus k. And we can rearrange that. So we end up with 16. So we end up with 16 over, get rid of the zeros, 16 over 20 equals e to the minus k. Ln of 16 over 20 equals minus k. And you plug that all into your calculator and you end up with k is 0.223. So our final model will be v equals 20,000 times by e to the minus 0.223 t. Right, the following information is available for car B. It depreciates more. Oh, sorry, I missed part B. The value of the car after 10 years is 2,000. Okay, so we're going to substitute t equals 10. There's part B. So v equals 20,000 times e to the minus 0.223 times by 10. When you plug that into your calculator, you get 2150. You say this is close to 2000. So it's close to 2000, therefore reliable. The following information is available for car B. It has the same value. It depreciates slower. So if it depreciates slower, it means we want to make how minus that k is less negative. So we want it to, like, if you like, you think of it almost like the gradient. The gradient will be less steep. So you could make, that's all you would say. You say the k value has to be larger or less negative. Okay, question 9. Oops. Right. So we've got 3 times 2 to the x meets 15 minus 2 to the x plus 1. Okay, so this isn't really it is an exponential, but it's more of just an indice question. So what we're going to do first, we're going to say, well, we've got 3 lots of 2 to the x on this side. 15 minus, and this is the same as 2 lots of 2 to the x, because remember, I can split that up and I can add those powers. So I'm going to put all the 2 to the x's on the same side. So I'm going to get 5 lots of 2 to the x equals 15. So 2 to the x equals 3. And then all you've got to do is whatever the thing is to the power is what we call our base. So x is going to be log to the correct base, which is 2, 3. And we're going to get x equals 2 log 3. Oh, it wants the exact coordinates, so we don't need to plug in our calculator. And that would be that solution. Okay. Question 10. A quantity of ethanol is heated, is modeled by the temperature. Given the initial temperature is 18, and after 10 seconds is 44. So initial tells us T is 0. So when T is 0, we know that theta equals 18. And we know when T equals 10, theta equals 44. So we've got 2 equations. So if we stick in T as 0, remember anything to the power of 0 becomes 1. So we're going to get A minus B. So we're going to 18 equals A minus B. And then 44 is going to equal A minus BE to the minus, times it by 10, 0.7. So you've got 2 equations, 2 unknowns. You can just use your calculator. So if you go to menu, you can go to equation, and you can go to simultaneous equations, and you can sub them in. or we can just do them together, take away from each other. So 40, we do 2 minus 3, 2 minus 1 even, 44 minus 18 to give us 26. The a's cancel, so we've got e to the power of minus 0.7. So we got minus that, minus minus 1. So we got e to the power of 0.7 minus e to minus 0.7. Yeah. So we get 26 equals 0.503b. So b equals 26 divided by answer, and we get 51.6. So you get 51.6, you sub it in to find a, and you get 69.6. So your complete equation is theta equals 69.6 minus 51.6 e to the minus 0.07t. Ethanol has a boiling point of 78. Use this to evaluate the model. Okay, ethanol has a boiling point of approximately 78. Well, what do we know? So this comes up a lot. When we have e to the minus something, what's happening? So let's think about our exponential curves. E to the x looks like this. It gets bigger and bigger and bigger and bigger. Think bacteria or lice or like gross things that just multiply and multiply. Whereas e to the minus x gets smaller and smaller and smaller and smaller and smaller, never hits 0 because there's an asymptote there, but gets closer and closer and closer to 0. So we know as t gets bigger and bigger and bigger to infinity, e to the minus 0.07t gets smaller and smaller and smaller towards 0. So that means the whole of theta goes towards 69.6, which is not 78. So we're going to say the max temperature of the model is 69.6, not appropriate, as lower, you're going to write it much nicer words than me, than 78. You've probably worked out, you know, me and words don't get on so well. Kind of why I did maths and then physics and yeah, and then chemistry. Anyway, question 11. Right, given that satisfies show that. So essentially they're getting rid of the logs. So we're going to use our log rules. Minus means divide. So this is going to be log A divided by B. Cancels the log on both sides. And then we're trying to make B the subject of the formula. So if we're making B the subject, multiply up by B. So we'll get BA minus B squared. Take B outside the bracket. Oh my God, wrong somewhere. AB minus B squared. Sorry, I'm making A the subject of the formula, not B. Ignore me. Put all the A's on one side. So we're going to end up with AB minus A equals B squared. Take A outside the bracket, we get B minus 1 equals B squared. And we can divide through, so we end up with the answer. So you'll end up with A equals B squared over B minus 1. Then it says, write down a full restriction on the value of B, explaining the reason. Well, we know for definite, remember, it's illegal to divide by 0. So that denominator can never be 0. So we straight away know that B cannot be 1 because it would make the denominator 0. But we also are told that A is bigger than 0. So for A to be bigger than 0, B squared minus over B minus 1 must also be bigger than 0, right? Which tells us we know it can't be 1, so B must be greater than 1. because as A is greater than 0, the whole thing is greater than 0. We know that it can't be 1. It's going to be bigger than 1. It can't be less than 1 because you've also got squared on the top there as well. Okay. And I think there's one last question. A new smartphone was released by a company. The company monitored the total number of phones, the rate of increase of n, so the differential was proportional to n. So essentially, now, I wouldn't worry too much about this, but what it's trying to get you to do is realize that it's not as one increases, it's talking about how if the rate increases, the other thing increases, which essentially is telling you you've got an exponential curve. So you know that n equals AE to, and it's going up, so it's not minus, KT. And that's all you had to write in order to get those 2 marks. All right, so I hope that was useful. I will be doing a full set of applied, I hope, in between different things today. It might be in the middle of the night. So you'll have to forgive any mistakes. I hope this has been useful. Thank you everyone that's left comments. I know I haven't really replied, but another 2 weeks of crazy and then I can breathe and I have some time. And we will clean up these videos. And if you're in year 12, hopefully this is useful for you next year. All right, take care. Bye-bye.